Now we are going to discuss equation of continuity. It's a very basic law which decides whether fluid flow is possible or not. Like, this is the most basic law of fluid mechanics. This is nothing but law of conservation of mass. It's nothing but law of conservation of mass. That's going to be the equation of continuity. Say, I'll discuss with you what is equation of continuity. Suppose we have this surface in a fluid system. This is the surface which you have in the fluid system. You have the fluid. This is a closed surface I'm taking. Suppose I consider an element of the surface ds. I consider the element of the surface ds. Say this is q vector. This is n vector. This is the fluid velocity q vector. So if I ask you that what is the amount of fluid, or amount instead of amount, that's a very confusing term, I write volume. Let's say, what is the volume of fluid flowing across the surface element ds. If I ask you what is the volume of the fluid flowing across the surface element ds, what's the volume? That is q dot nds. The volume of fluid flowing across the surface element ds, and of course per unit time. That's q dot nds. Like say you have a pipeline and I am asking you how much fluid is coming out per unit time. What is the volume of fluid coming out per unit time? How do you find it out? Since the fluid travels a distance of v in 1 second, so all the fluid which is lying in this length v will come out. So a into v fluid will come out. But here you are seeing that this surface n and q lie in same direction. So q dot n becomes q and area ds, q into area. So it becomes a into v. But in general, I don't have n coinciding with q. See, I repeat what I told you. If this is a flow tube, right? If I ask you how much fluid has come in 1 second, then you know that fluid has moved. Fluid moves by a distance of v in next 1 second. So all this fluid which is lying in this volume will come out in next 1 second. And what's the fluid inside? That's a into v, right? So that's why on the similar analogy I am writing this. Why I have written dot product? Dot product is because, see, here your n to this s, this was your s, so normal to s was lying in direction of v. So q dot nds become q ds. ds is a over here. Okay, but in general I can't write this because q may not lie always in the direction of n. Suppose if the fluid is flowing parallel to the wall, if fluid is flowing parallel to the wall of the surface, in that case the fluid is neither going in nor coming out, it's flowing parallel. In that case q dot n becomes 0. If q is flowing parallel to the wall, q dot n becomes 0. And if fluid is flowing in, then actually the fluid is not coming out, it's flowing in. So in that case theta is obtuse and q dot n is negative. So if it is positive, fluid is coming out. If it is 0, it means fluid is not coming out, not going in. If it is negative, it means fluid is flowing in. So in general I write it like this, q dot nds. And if I ask you what is a mass of fluid, what is mass of fluid flowing across the surface element ds per unit time, that is rho q dot nds, rho q dot nds. This is a mass of fluid flowing across ds per unit time. And if I write total or mass of fluid flowing across the entire surface per unit time, if I ask you this, in that case mass of fluid flowing across entire surface per unit time is going to be, this is rho q dot nds. Is rho q dot nds. This is the mass of entire fluid flowing across the surface per unit time. So if this is called flux, this is called flux, right? Flux of rho q gives you, flux of rho q across the entire surface gives you mass of fluid flowing across the entire surface per unit time. So if the fluid is flowing out, what do you say about the mass of the fluid inside? If the fluid is flowing out, if this is positive, in that case, what do you say about the mass of fluid which is inside? What is d by dt of the mass of fluid inside? Mass of the fluid inside is rho d tau. If this is positive, it means fluid is flowing out. Then in that case, what will be this? This will be negative. So it will be in magnitude, mass of fluid flowing across the entire surface per unit time should be equal to the rate at which the mass of fluid is going down inside. In magnitude, they should be equal, but opposite in sign. If the flux is zero, we might infer that fluid is not flowing out, not flowing it, but you may also infer the amount of fluid flowing in is equal to the amount of fluid flowing out. In any case, the mass of fluid inside won't change. So d by dt of rho d tau is 0 in that case. So if flux is 0, d by dt of the mass is also 0. If it is negative means the fluid is flowing in. When fluid is flowing in, the mass inside is going to increase, and this will be positive in that case. So if this is negative, this will be positive. So in general, what I can write is this is equal to rho d tau. This is S, this is V. S is the bounding surface of V. This is V, this is S. So the amount of fluid flowing across the entire surface per unit time is equal to negative rate of change of mass of the fluid which lies inside. And this is the equation of continuity. This is the equation of continuity. This is what we call equation of continuity. Alright. So the mass of fluid flowing across the surface is equal to the rate at which mass of fluid is changing inside. So it's an equation of continuity. You might have read an expression at 10 plus 2 level. In your 10 plus 2 level, you read something like, if I remember, this is rho into A into V is constant. You read like this, that the density into area into volume, velocity. Density into area to velocity is constant. I hope you remember this. This is the expression which you read at 10 plus 2 level. Rho A1 V1 equals to rho A2 V2. So how this comes? I told you that this is the equation of continuity. Then how this comes from this expression, how it leads to this expression. See, this is in general expression. This is in general true for, this is in general expression of equation of continuity. This is a very special case. What you have read at 10 plus 2 level is very special case. I'll tell you what is this, how it comes. So you see, your equation of continuity is rho q dot nds is rho d tau. This is S and this is V. See, in 10 plus 2 what you have read is basically flow tube. You read something like this. This is a flow tube. It's a tube of flow with no leakage. The fluid is entering over here with say velocity q1 and fluid comes out with the velocity say q2. It goes in with q1 and comes out with q2. Right? This is a flow tube. This is a flow tube. So whatever fluid is going in is the fluid coming out. Right? Whatever fluid goes in is the fluid coming out. So in that case, the mass of fluid which is inside should be same. Should not change. There is no vacuum created. Whatever mass is going in, that same amount of mass is coming out per unit time. So this part is going to be 0. So it means if I consider a closed surface which is enclosing the whole flow tube, this closed surface will consist of S1, S2 and the curved surface S3. So it means the flux of rho Q over S1, I can say rho Q n ds over S, and S consists of what? S1, S2 and S3. So this is flux of rho Q over S1 flux of rho Q over S2 and flux of rho Q over S3. Okay, so over S3, see, no fluid is flowing out of S3. Flow tube is without any hole. There is no hole. There is no sink or source. Fluid is not flowing out of S3. In any case, on S3, fluid is flowing along S3. So the angle will also be 90. So Q dot N. Okay, fluid is flowing obviously along the boundary. So N is perpendicular to Q. So in that case, this is going to be 0. So across S1, I can say N is an outward drawn normal. N is an outward drawn normal. This is going to be our N and this is going to be our N. So, and Q is this. This is your Q. Let's say Q1. So it is Q dot N is going to be Q dot N on S1 is minus Q1. So it is minus Q1, so rho Q1 ds, right? And here Q dot N is going to be Q2. So it is rho Q2 ds. So say rho is rho 1 over here and rho is say rho 2 over here. In that case it is rho 1 Q1 ds and this is 0 also because this part is 0, and rho 2 Q2 ds equal to 0. So this will come as minus rho 1 Q1 S1, it's rho 2 Q2 S2 equal to 0. Rho 1 Q1 S1 is rho 2 Q2 S2. That's what you read in 10 plus 2. It was for flow tube, right? But in general expression is this. At graduate level you must know this. What is this? Okay, So this is all about equation of continuity. It's all about equation of continuity.